XCAM's journey towards developing space projects and space products is a fairly recent one over the last 10 years. The company had traditionally been building custom camera systems for science and high performance manufacturing applications, in particular ultra clean camera systems for vacuum systems. And a lot of that knowledge and understanding of developing those systems is very translatable into developing systems for space. So XCAM started around about just over 10 years ago developing systems for spacecraft.
There was a big transition point for the business about 2008, where the world's first soft X-ray laser was about to be turned on in Germany in September, I think. And it was going to transform science. It was going to enable scientists to take diffraction images of non-crystalline objects like mimiviruses and things like that. And the scientists that were going to use this facility, they were going to be the first in the world ever to use this facility, suddenly heard their camera couldn't be made 4 months before turn-on of the laser. And they contacted Teledyne E2V to ask if they had any detectors they could use, and they said yes. And they then said, well, who can make us a camera in 4 months flat? And they recommended XCAM. And we went on to make a triple camera system in 4 months flat from existing subsystems that went on to take the world's first diffraction image of the mimivirus and win us a national award. We had a Japanese customer visited soon after, and he said, it seems like the whole world is talking about XCAM and what you've done. And that was a real turning point for us. That was where we started to become a lot more noticed, and our business started to grow.
So with the scientific and industrial systems which XCAM had been developing since its conception, there are a number of different kind of innovations which XCAM has had to develop along the way in order to meet the very demanding customer requirements. Some of those innovations, for example, being able to develop systems which are ultra clean and control contamination, are very useful and very immediate for the concerns of the space sector.
Whilst historically we made cameras for very clean vacuum systems, that knowledge and expertise is translating quite well into the space industry, which is obviously a rapidly growing and huge potential area for us.
So the Space Particle Fallout Monitor is a very unique instrument. It effectively measures particles falling out of the atmosphere, which in a clean room environment, which is where spacecraft are typically manufactured, is very important to ensure that your spacecraft are manufactured clean. Currently within the industry, particle fallout is monitored using glass slides. So the particles fall onto a glass slide. That glass slide is collected by one of the cleanroom operators and then analysed in a microscope to determine how many particles there are. We were approached by the European Space Agency to investigate how we could measure particles during the launch of a rocket, and glass slides are not going to be the solution for that. So we were looking for the development of a digital real-time method for doing that. And so over the last few years, we have been going through a number of stages of product development to develop such an instrument.
So the original Space PFO was a contract which was issued by ESA. It was to design a breadboard system for particle fallout monitoring. We were successful in winning the contract to do that, and the first PFO monitor was born. So other devices that are on the system are turned off during launch, so they don't necessarily need to operate. So things like I guess micro disconnects on connectors or anything like that wouldn't be an issue because they're not operating at that point. As soon as they get up into space, it's quite benign, and then the shock and vibration aren't an issue.
So the future of the space industry, certainly within the next 15 years or so, is looking very positive. And even beyond that, there's a very strong science and engineering program moving forward as we look towards being partners within the European Space Agency, with the Lunar Gateway and various other programs going back to the moon and the exploration to Mars. There's also a growing sector within the Earth observation side of things, where we're looking down at the Earth, and also within kind of telecommunications and even in space manufacturing. The UK is very much at the forefront of that, and as a UK company, XCAM benefits from that kind of national and international ecosystem, which helps to build capability, knowledge, expertise, and really get the next generation of engineers and scientists excited about working in this sector.